remaining part the remaining part of the section 3.7 example. From this the above equations we get minus c1 plus 3c2 equal to 0, minus c1 plus 3c2 equal to 0. That implies c1 equal to 3c2. So p of x will become y of x equal to lambda into c1 minus c2x. From this we get a equal to 2c1, that equal to 6c2. Then the eigenfunction corresponding the eigenvalue lambda equal to 2 is 1 minus x. Similarly, lambda equal to minus 2 is a eigenvalue. Then from this we get the eigenfunction 1 minus 3x. So the eigenvalues of the integral 1 minus 3x and lambda equal to 2, then 1 minus x. This is the result of the equation. Now the equation y of x equal to lambda into c1 minus 3c2x plus f of x. So that the solution of the given integral equation will be written as y of x equal to f of x plus d1 into 1 minus x plus d2 into 1 minus 3x. The eigen functions are 1 minus x and 1 minus 3x. That means f of x plus combination of eigen functions, where d1 equal to 3 lambda c1 minus c2 by 2, d2 equal to lambda into 3 c2 minus c1 by 2. Thus this is the functions d1 and d2. Thus it follows that any solution p of 1 can be expressed f of x and some linear combination. Consider the second case. F of x not equal to 0, lambda not equal to plus or minus 2. In the integral equation, if lambda equal to 2, integral 0 to 1, 1 minus x f of x dx, that equal to 0. And show that no solution exists unless 1 minus x is orthogonal to f of x is 1 minus x orthogonal to f of x over the interval 0 1. If f of x is orthogonal to 1 minus x, then the equation minus c1 plus 3c2, that equal to integral 0 to 1 f of x dx, and minus c1 plus 3c2, the second equation x f of x dx, are equivalents. Then we obtain c1, that equal to c2 3c2 minus negative 0 to 1 f of x dx. From this equation p of 2 becomes y of x, that equal to 2 into 3c2 minus integral 0 to 1 f of x dx minus 3c2x plus f of x, that equal to a into 1 minus x, a into 1 minus x integral 2 into integral 0 to 1 f of x dx plus f of x. Here a is 6c2, it's an arbitrary constant. Similarly, if lambda equal to minus 2, if lambda equal to minus 2, y of x equal to b into 1 minus 3x minus 2 by 3 integral 0 to 1 f of x dx plus f of x. Here b is any arbitrary constant. The first we get a arbitrary constant, here b is any arbitrary constant. This also infinitely many solutions. Okay, a and b, this also infinitely many solutions, and the difference between any two such solution is by multiple of eigenfunction corresponding to lambda equal to minus 2.